This is RoopaPrasad, Department of Assistant Professor, Department of Computer Applications, MITS College. So today we are going to discuss a topic called as HMAC, that we call it as a hash message authentication code. Okay, and we have already previously discussed in previous presentations like hash functions, and we have discussed about the hash algorithm also. MAC also we discussed, and one of the variation is HMAC, that is called as a hash message authentication code. Okay, coming to the contents of this presentation, first we will discuss about the HMAC overview, that is the HMAC overview. Then we will discuss how this HMAC is going to work. Then we are going for the algorithm and we discuss the step-by-step process. And finally, we go for the HMAC features. Actually, this HMAC is a message authentication code mechanism. HMAC is a message authentication code mechanism that uses a hash function and a secret key to verify the integrity and authenticity of the message. Actually, this hash function is used to verify the integrity of the message, whereas this MAC uses a secret key in order to ensure the integrity as well as the authenticity of the message. And the combination of these two result in a new mechanism that we call it as a HMAC. That is a new algorithm, which is the result of the combination of hash function and a secret key, that we call it as HMAC. And coming to the purpose of HMAC, so this HMAC ensures the data integrity and it also ensures the data authenticity. Actually, this MAC, that is a message authentication code algorithm, also ensures the data integrity and authenticity. Then why we are going for this HMAC is, so this HMAC, that we will discuss. So hash function, only with hash function we can ensure the integrity, that we already discussed in previous presentations, how we can ensure the integrity by using the hash function, by using any hash algorithm. Okay, and this MAC is going to ensure authenticity, and in addition to authenticity, it is also ensuring the integrity. So this cryptographic hash function such as MD5 and SHA-1 generally execute faster in software than symmetric block ciphers such as the DES. So in order to use instead of using MAC, why people are prefer to use the hash function means because these execute faster in the software. That is a reason why the people are going to prefer MAC instead of the hash. Why the people are going to prefer hash function instead of the MAC. While MAC ensures both authenticity as well as the integrity, whereas the hash function ensures also only integrity. Even though the people are interested to use this cryptographic hash functions means because it generally executes faster in the software. So this hash function such as SHA is a secure hash algorithm, which is the most popular hash function algorithm. So this is not designed to use the MAC. Okay, so it is not going to use any key in order to perform the hash SHA. So this hash function is not going to use designed for use as a MAC and cannot be used directly for that purpose because it does not rely on the secret key, because it ensures the integrity but it does not ensure the authenticity. But there is a proposal to incorporate the secret key into the existing hash algorithm, and that result in the HMAC algorithm. Okay, actually hash function ensures the integrity, whereas the MAC ensures both integrity as well as authenticity. Okay, instead it is going to ensure the integrity and authenticity. People are preferring to use the hash function. Why? Because it executes faster in the software. Okay, so there is a proposal to incorporate the secret key into the existing hash algorithm. This hash algorithm is a secure algorithm. So there has been a proposal to incorporate the secret key, which is not supported by the SHA, that is a secure hash algorithm. So this approach raises to the support of HMAC, that is the hash message authentication code. And this HMAC is issued as RFC 2104, and it is chosen as a mandatory to implement MAC for IP security. And it is used in other internet protocols such as SSL. So this HMAC has also been issued as NIST standard, that is given in FIPS 198. That is about the overview of hack. So coming to this overview once again. So what is a HMAC? HMAC is a combination of hash function and the secret key. This hash function is incorporated with the secret key in order to produce a new code that we call it as a HMAC. So HMAC uses a hash function. Generally, it uses a SHA-256 along with the secret key to generate a MAC. Okay, this hash function generates the hash code, but it does not use a secret key, so it ensures only integrity. So this HMAC uses a hash function along with the secret key to generate the MAC which ensures authenticity. In addition to authenticity, it also ensures the integrity. So it is very secure and it is widely used. And coming to how this HMAC works. So this HMAC algorithm uses a message, and it uses a shared secret key called as K, and it is using a cryptographic hash function like SHA-256, MD5 or SHA-1. Any algorithm can be used in order to generate the MAC, which ensures the authenticity as well as the integrity of the message. So we discuss about the algorithm stepwise. So in step 1, what you are going to do means we are going for the key processing. That is, we are going to take a shared key if the key is longer than the block size of the hash algorithm. As we already know that a hash function, that is a hash algorithm, divides the messages into equal blocks. So if the key is longer than the block size, then we can able to hash it directly. Otherwise, we are going to pad it with zeros to make it exactly the block size length. So the key size should be equal to the block size of the hash algorithm. Okay. Then in the step 2, we are going to prepare padding constants. We are going to prepare the padding constants. So here we are going to make use of two constants. That one we call it as IPAD and second one we call it as outpad. That is inner padding, and second one is called as a outer padding. So in inner padding, what you are going to do means you are going to repeat this sequence so that it matches the block size. So the key should be matched to the block size of the message. So the key in inner padding, what we are going to do, we are going to take the hexadecimal value, and this value is repeated until it reaches the block size. Okay. Then in OPAD, that is the OPAD constant, how we are going to prepare this OPAD constant means we are taking this hexadecimal value, that is 0x5c, and this value is repeated in order to reach the length of the block size. That is, it is equal to the IPAD. Okay. So this 0x36 is and 0x5c is a hexadecimal values for the binary numbers. That is for 0x36, the binary number is 00110110, and for this 0x5c, the binary value is 0101110. Okay. So these are called as the padding constants. Why? Because we are going to pad in order to make the key is equal to the block size. Okay. And next we have to perform the inner hash. First we perform the inner hash. So after making the key constant, that is a K, that is the inner key, that is the key. First we have to pad the keys. Then we have to make the IPAD. We have to prepare the IPAD. Then this IPAD is XORed with the key. This IPAD is XORed with the key. And the total has to be the XORed with IPAD is XORed with key. So we get one result. That result is mapped to message. That result is mapped to the message, and this whole thing has to be performed hash. This whole thing has to be given to the hash function so that it generates one code. Okay. So what happens? We are going to first XOR the key. What we have taken as the secret key with IPAD, that is a constant, inner padding constant. After performing XOR operation, we have to concatenate the result with the message M. Okay. Then the whole thing, that is this pattern message has to be given to the hash function. This we call it as an inner hash. Then we have to go for the outer hash. So outer hash, how we are going to perform outer hash means same key will be taken, secret key will be taken, that is XORed with another constant that we have prepared, that is called as an OPAD. That should be XORed. The result has to be concatenated with the inner hash. Then the whole thing has to be given to the hash function to produce a final MAC output. That is the final MAC code, which is going to ensure the integrity as well as the authenticity of the message. Okay. So that see the overall thing. The inner hash, what the inner hash is going to do means it binds the secret key with the message. First step, inner hash. Inner hash is going to bind the secret key with the message. Then outer hash, what it is going to do means it is wrap that securely with the second key dependent step. Those are the things that are going to be performed by the inner hash as well as the outer hash without knowing the key. Okay, if the key is not known to attacker, he cannot forge a valid HMAC. So, in order to generate a HMAC, he must know the key as well as the in part as well as the out part. This is the whole thing how we are going to apply the HMAC on the message. So, this HMAC make use of a key. So, what is going to perform? That key is XORed with. So, this is the inner step. The key is XORed with I part. So, the result is concatenated with message. Then the whole thing will be hashed. The hash output is XORed, is concatenated with the key concatenated with O part, and the whole thing has to be given to the hash function in order to generate the final HMAC. That we will show diagrammatically also. See here we have a key. Okay, we have a key that is a secret key. This secret key has to be padded with zeros so that it is equal to the block size. This is the block size of the message. According to the hash algorithm, the message has to be divided into equal size blocks. So the key should be equal to the block size. Then this iPad is also equal to the block size. This iPad is generated, that is we already discussed 0x36, the repetition of 0x36 hexadecimal. So it is a constant. So these two are XORed. That key is XORed with I part in order to produce SI, that is the input. Okay. So this SI is concatenated with the message. As we understand why you are going to for the padding. Why? Because it should be the equal size of the block. That's why we are doing the padding. So it produces the same block size, that is equivalent to the block size of the message. So along with the message, we are going to place the S1, that is a result SI, that is a result of the key and the iPad XOR. So that is given to the hash function, that is a normal hash function algorithm we can use, SHA-256 algorithm. So IV is an initialization vector which is given as an input, which produces n bits, that is the result of SI concatenated with the message and the code, that is the code. This hash code is padded to B bits, and we are going to take another constant, that is O part, which is concatenated with the same key. So in order to get SO, that is the output, so outer padding, so it has to be concatenated with the result of the inner hash, and the final thing has to be given to the hash function in order to produce a code that we call it as a HMAC, which is the result of the key and the message, I hope you understand. So first we have to perform inner hash, then we have to go for the outer hash. In the inner hash, what we are going to do? We are going to take the key that is XORed with iPad. iPad is a constant, inner padding constant. We are getting the output, which is equal to the block size of the message block. Then that should be concatenated with the message. The whole thing is given to the hash algorithm. Hash algorithm works similarly. Okay, so it produces the output. It produces the n-bit outputs. So if then it has to part to B bits. We have to make to the equal block size. Then we are going to get SO, which is the result of XOR operation of key at the O part, that is the outer padding constant. So that after concatenating, we have to give the whole thing to the hash algorithm to produce the n bits HMAC. That is an important peculiarity of the hash function. So hash algorithm, what is this going to do? The message can be of variable length, but it produces a fixed length output. Like that, we are going to get the HMAC, which is very secure, because the hash algorithm is included with the key, is incorporated with the key. So we are going to get a powerful code that is called as a HMAC, which ensures the integrity as well as the authenticity of the message. And finally, coming to the features of this HMAC, we can use any standard hash function, okay, like SHA-256. any hash algorithm can be used, and key in the hash makes it much stronger than just hashing. Just hashing is less stronger than the keyed hashing. Keyed hashing makes it much stronger than just hashing. And it is used in many protocols like IPsec protocol, that is application layer security protocol, network security protocol, then SSL, that is a transport layer security protocol, and HTTPS, which is application layer security protocol. In all these protocols, we can make use of the HMAC. So, for example, what we can say in IPsec, we can use HMAC to authenticate the IP packets. In order to authenticate the IP packets, we are going to make use of a HMAC algorithm. So, if the computed HMAC, how we are going to ensure the integrity, authenticate in order to authenticate also, and in order to ensure integrity also. So, if the computed HMAC at the receiver matches the received one, then we can say the packet is authenticated and untampered. Like that, we can prove the authentication as well as the integrity. So this is the topic about HMAC algorithm, that is a hash message authentication code algorithm. And this material is prepared is based on the book called Cryptography and Network Security Principles and Practices, 4th edition by William Stallings. So if you have any queries about this presentation, you can contact the firm. Okay, hope you understand. Thank you.